all those millions of viewers I have, I'm recording for them, not for y'all, it's for all my millions of viewers. Here we go. You said pi over 2. You needed to see that whole thing all the way through. Okay? Pi over 2 is what in degrees? Come on, y'all. 90 degrees. Very good. Pi over 2 is equal to 90 degrees. That terminal point, that ordered pair, is 0, 1. I have some of you flipping those numbers when you're filling in your unit circle. Crazy. Don't do that. Okay? 0, 1. Now, we're no longer thinking x and y. We're thinking in terms of what? Say who? Cosine, sine, right? How do we keep them straight? C comes before S. It's in alphabetical order. So here we go. And this is what I do, folks. I always set it up this way. Some of you are wanting to save space, so you go sine, cosine, tangent, cosecant, secant. Don't put it across from each other. We got paper. I got plenty of paper I will let you have. Back there in them crates. That's what they're there for, okay? Do it this way so I can keep, mainly for my grading purposes, when I grade something, I guess I'll put blanks, so you'll just fill in the blanks. Don't worry about it. Rewind what I just said. Don't watch this part of the video. Here we go. What is sine of pi over 2? 1. It's right here. It's in the ordered pair. It's 1. Or 1 over 1, right? I can write 1 under anything. Cosine of pi over 2 is what, folks? 0 or 0 over 1. I need to think 0 over 1 because that's going to help me in just a few minutes. Tangent, how do I find tangent? Because this is really the only one I have to calculate to figure out. It is sine divided by cosine, isn't it? And I'm going old school. I have to go old school. Sine divided by cosine. I'm going to multiply by the reciprocal. Check this out. Look what happens. When you multiply across, you get 1 over 0. What's my answer? When 0 is under the fraction bar, the term is undefined. I know that is silly. I don't even care. Y'all ought to know that. The sillier it is, the more I will remember it forever. So I got to do what I could, I don't have a whole lot of room up here. I got a lot of information up here in this noggin. I can't have a lot of clutter. I need important stuff. So under is just undefined. I don't have to know anything. All I know is under. Undefined. Now we're going to find the inverses. What's the inverse of sine? Don't tell me the number. Tell me the name of the inverse of sine. CSC, which is cosecant. Good. Cosecant of pi over 2. If I flip 1 over 1, what do I get? 1 over 1, which is 1. What is the inverse of cosine? Secant. And when I flip, because it's just a reciprocal, 0 over 1, that gives me 1 over 0. Uh-oh, what is it? Undefined. And what is the inverse of tangent? Cotangent. So, here it is, 1 over 0. Flip it. What's 0 divided by any number? 0. Now we're good. How many of you had that? Or if you didn't, few hands, okay? If you didn't, does this make more sense? Was it the undefined thing that threw you? Yeah? Does it make sense now? Okay, I saw a head nod, yes. Questions at all? We're going to move on with this, and you will see how simple this is. We're just talking reciprocals, are we not? And a reciprocal is nothing more than, this is a universal sign for reciprocal. I just made that up. I don't know if it is. But it's just a flip. Flip the fraction. Okay? Flip the fraction. Check this out. We are going to continue with this section Naming all those trig functions. You're still talking. Here we go. Name all 6 trig functions of the following angles. Okay? So we're going to look at this. Our angle T is 4 pi over 3. Some of you can look at this right now and you already know. You're locked in. You know where this angle is without even putting it to paper. You know where it is. You know the terminal point. How many of you can do that? And it's not bragging, it's just being real. How many of you can look at it and go, yeah, I already know what it is? Hands up, not this right here. Hands up. Be proud that you can do that. Okay. I kind of sort of want to elbow drop you with love that you can do that. Because what do you know? Y'all know what I have to do. It does not matter how many times I have graphed this angle, I have to do what? I got to graph this angle. Graph it. I'm visual. I have to graph it. I envy you if you don't have to do this. How will I prepare my graph? Skinny. I heard somebody say it. Skinny. And what else will I do? Take it. Squiggle. Squiggle out that y-axis. We don't need it. And when I rotate my angle, what's it going to be? A rotation up or down? Up. And that's 3 and 4. So I land in the 3rd quadrant. Do you guys agree with me? What's the terminal point? Okay. Did you see me just do it? I have to do that because it allows me to know that my terminal point is -1/2 negative root 3 over 2. Did you see me move my hand though? I start in the 1st quadrant. 3, 2, 1, and then I have to work my way over. I do it every time. Now, how many calculations do I actually have to make? Just one. Just one. Because I already have 2 of these things up here. The sine of 4 pi over 3 is what, y'all? Negative root 3 over 2. Hey, time out. I hope that if you got your paper back and you were putting negative signs underneath that radical, I hope you did not do that this time. I hope you notice that I have to take off because a negative number under a radical gives me what kind of an answer? An imaginary, okay? I think maybe there were just a few little people doing that. I hope you corrected it this time. Notice that my negative sign is outside my radical. Hey, what's cosine? Of 4 pi over 3. One more time. -1/2. Everybody with me so far? Facile or difficile? Muy fácil. Holy fácil. What about this tangent thing? Now I got to do a little calculating, right? What do I calculate to find the tangent? Y over x, but Zechariah, no more x and y. No more x and y for you. Who? Who? Sine over cosine? Have y'all seen the Soup Nazi episode of Seinfeld? No more soup for you. Have y'all not seen that? Is that what you just said?
No, like my mom, one time we were going out with Ethan.
Okay, class. Always serious in this trick class. Never any jokes. Fun is for losers. No laughing. Stop it. No more laughs for you. Sine divided by cosine. Fun is overrated, y'all. Having fun is no fun at all. So stop smiling. Don't smile the rest of this class. Stop it. I'm not even looking. What is sine? I'm not smiling, and I'm not going to make another joke. Because laughing hurts. No, it doesn't. That's a lie. Laughing's awesome. Here we go. I'm going old school, of course, because I have to. Ain't nothing wrong with old school. Don't be hating on old school. But a negative divided by a negative is a positive. Thank you very much. And look what ends up happening. Can I cross cancel here? And it ends up being positive root 3, doesn't it? So the tangent of my angle ends up being plain old root 3. Right on? Am I ready to write all my inverses? Yep. Here we go. What's the inverse of sine? Tell me, don't tell me the value, tell me what it's called. Cosecant. Cosecant of 4 pi over 3. Oh, gotta do a little fixing up, don't we? Go ahead. Negative times negative is a positive. Okay, yes ma'am?
Why did you flip the negative 1 half?
Because I am multiplying by the reciprocal. Old school division. Just multiply. Nip. And the cosecant of 4 pi over 3 is, we're going to just flip that over. We're going to take negative root 3 over 2, and we're going to flip it over. I should have just flipped it over. And folks, we got to clean that up because we have to rationalize, okay? So we're going to multiply by root 3 over 3, root 3 over root 3. And then we're going to multiply across, and we're going to end up with negative 2 root 3 over positive 3. Do you guys agree with that? Okay? Whatever's in the denominator. What I'm actually doing is I'm multiplying by 1. It just looks weird. Bless you. The reason I have to multiply by 1 is it won't change the value of the number. Okay? So, in order for me to multiply by root 3 over root 3, what ends up happening? What's the square root of 3 times square root of 3? Square root of 9. What's the square root of 9? Plain old 3. Hey, my radical's gone. Okay? But what I'm actually doing is multiplying by 1, it just, in a weird way. Okay? Now, we found cosecant. Let's find secant. Folks, what's the reciprocal of negative 1/2? Negative 2 over 1. Clean that up and it'd just be plain old negative 2, right? Right? Yeah. I can put it over 1. I just flipped my negative 1/2 over. And then we've got to take care of cotangent. Now, if you look, negative, nope, root 3, plain old square root of 3. If I flip that over, what's going to be on top? 1. All right, so that's going to give me 1 over root 3. What do I do, Morgan? Times it by root 3 over root 3, which is actually like multiplying by what? 1. Root 3 over plain old 3, right on? Folks, this is really very simple. It isn't anything complicated. Maybe the worst part will be figuring out tangent and then rationalizing some of your fractions. That's the worst part of this. It's not difficult at all. Let's look at another one. Anybody have questions on this? The inverses are just the reciprocals. Please stop talking while I'm talking. Here's another one. Very simple. What if I were to change it up like this? I want you just to find the sine of 7 pi over 6. Just the sine of 7 pi over 6. What do I have to do to this first? I got to graph it, okay? I've got to graph it. I'm going to prepare my graph with the 2 x's. And then I'm going to rotate up. Not on pi over 6 angles. The only one you mark out that y-axis is on which angles, folks? Pi over 3. That's the only one. Now, when I graph that, all right, see, did y'all see what I just did to figure out my ordered pair? Started over here. Did you guys get negative root 3 over 2, negative 1/2? How many of you had that hands up? Very good, very good. What's the sine value for that angle? Negative 1/2. And just for kicks, how many of you had that hands up? Ha! There we go, out of class. How about this one? Okay? Because are they always going to be that easy? I know. No, they're not always going to be that easy. How about this one? Same angle, but I want you to tell me the secant of 7 pi over 6. What do we do now? Do what? 7 pi over 6. I want to find the secant of that angle, 7 pi over 6. What do I do? What do I do, Seth? Oh, I got to find the cosine first. Why do I have to find the cosine first, Seth? Because it's the inverse of secant. So what is, find cosine first, which is what, obviously? Negative root 3 over 2. And now what? Flip it, and I get 2. I'm going to put my negative at the top, over root 3. Now let me time out here just a second. I don't want this negative sign to fool you. I don't want you to make a careless mistake because of a sinking negative sign. Always think of your negatives as being floating negatives. They either have to be at the top, or they have to be at the bottom, or they have to be smack dab in the middle, right directly in front of the fraction bar. They can't be both places. Why? Because then it'd be a positive number, okay? So instead of me having this negative in front of that square root of 3, I'm just going to float it to the top, leave it there, okay? And then I've got to clean this up. How? Multiply by, what do I multiply by? Root 3 over root 3, which is actually just multiplying by what? It's just 1. It's just actually just 1. And I get negative 2 root 3 over 3. So what is that? Negative 2 root 3 over 3. What is it? That's the secant of the angle 7 pi over 6. Comprende? Facile or difficile? How many of you say, I see. Okay, so far that's all right. That's cool. All right, let's look at another one. Guys, I want you to do this one yourselves. I want you to solve for, we'll make you cry. I want you to find the cotangent of 5 pi over 3. And I want you to do this yourselves. You may work with the person beside you, in front of you, behind you. But I'm going to give you like 2 minutes to figure this out. Go. Folks, did you get your terminal point to be 1/2 negative root 3 over 2? Okay. What do I do? Luke Easter, tell me. You want to find the tangent first, and then you want to, once you find it, you want to flip it over. Did anybody do it a different way? Okay. Okay. There's a shortcut, and I'm going to show you the shortcut in just a second. And that's a lie. In a few minutes. Here we go. We got to find the tangent first. Tangent, hold that thought. Tangent is going to be sine divided by cosine. Do you guys agree with that? Yeah. All right, sine is what value? Negative root 3 over 2 divided by my cosine value, which is a half. You guys cool with that? Okay. That gives me negative root 3 over 2. I'm going to multiply by the reciprocal. My 2's cancel, and I'm left with negative root 3 over 1. Do you guys agree? That is the tangent of 5 pi over 3. Okay? I don't want tangent. I want cotangent. So what am I going to do? Flip that sucker over. So the cotangent of 5 pi over 3, when I flip this thing over, is going to be negative 1 over root 3. Hello, what do I have to do to that? I got to multiply by root 3 over root 3, which gives me negative root 3 over plain old 3. And that is my cotangent of that angle, 5 pi over 3. How many of you had negative root 3 over 3? High five, folks. Good job. You want to know about the shortcut? That would have cut out all the beginning of that. Say what? Shortcut. Write this down. Shortcut. Folks, isn't cotangent just cosine divided by sine? Didn't we write that somewhere yesterday? And all of that mess, it's there in your notes, okay? And if you remember, that all it would have done is it would have cut out all that beginning work and then that flipping work, okay? We wouldn't have had to do any of that. We would have just gone straight to our cosine value 1/2 divided by negative root 3 over 2, multiply by the reciprocal, and then solve or simplify, okay? And it would have saved us a whole lot of work. Now, the thing you got to remember, as always, there's more than one way to what? More than one way to skin a cat. I don't care how you solve, as long as we all get to the same answer at the end. Right on? Okay? Questions at all? Are you still feeling like this is facile? Hands up. If you feel like it's facile, go whoop. See if you were listening instead of talking. Do you feel like this is easy? Yep. Okay. All right, here's another one. Since you feel like this is so easy, I'm going to make this not so easy, because that's always fun as a teacher. I want you to find cosecant if sine of 7 pi over 6 is equal to negative 1/2. What is it? Just worded a different way. Find cosecant if you're given that the sine of the angle 7 pi over 6 is equal to negative 1/2. Kelly, what are you thinking? What are you thinking? What is it? Nope. Mm-mm. What? Say it again. Why is it negative 2? Because just cosecant is the reciprocal of sine, isn't it? So just flip it over. Cosecant of 7 pi over 6 is negative 2, isn't it? It's not just like cruel. What I put a box around. That the cosecant of that angle is negative 2. This is the same thing we've been asked, but we're given this information. All you have to do is flip it or find exactly what it tells it. Sometimes you're not going to have to find all 6 trig ratios. You're only going to have to you're only going to have to find what you're told. You may only be told to find the cosecant of that. Okay? 2 more and we're done. Pardon? We're done after this. Get that off the wall. With your laser beam of sunlight. I ain't stupid. Do that one, and then do this one. Laser beam of sunlight. Go on and do it, I dare you. Just remember, I know how to wrestle. And I'm probably bigger than you are. Wrestle. Why is Rock going back to wrestling? Seriously. Dwayne Johnson's got it going on. He does not need to wrestle. For real. Wrestle. Do this. You just said that out loud. All right, here we go. Folks, what do I do for the first one? I want you to find secant of the angle when you're given the cosine. What do I do? Flip it. So I've got -2 over √3. What do I do? Rationalize. How many of you got -2 √3 over 3? Let me look. Hands up. High five. Boom. How about 7? I flipped it and rationalized. Ah, good. Making you think. Good. What do I do for the next one? How do I find tangent of pi over 3 when the cotangent is √3 over 3? What do I do? Come on. Flip it. Holy moly. 3 over √3. Ooh, what do I do? Rationalize. And I'm actually multiplying by what number? Y. It does equal 1, but why do I multiply by 1 in this form? Doesn't change the value. Very good. Multiplying by 1 never changes the value. I get 3 over √3 over that right there. You know what I'm trying to say. Is that it? Mark them all out? No. No, just the ones on the outside. Why? It's in the house. It's protected. How many of you had √3? High five. What's for homework? Liars. All of you. Liars. Here we go. Page 130. And I'm going to go bust him. Here we go. Folks, page 130. Page 130, I want you to do 13 through 22. Folks, there are 2 parts in A and B. It's really simple, this little piece. But then I want you to think about this. Okay? This is going to lead us into tomorrow. Now you're thinking and then doing. If your terminal point is 1/3, 4/5. Find all 6 trig functions. Never fear. You're welcome. If your terminal point is 1/3, 4/5, find all 6 trig functions. Piece of cake. This is easy. Don't make this difficult. Just because these are weird numbers we haven't seen before, it doesn't matter. Okay? You got this. Use your time wise.